So the first one, what I have to know in friction formula means about types of friction. I'm classifying them into static friction and kinetic friction and rolling friction. Static, kinetic, and rolling. Mainly here, coming to about static as when the body is in the rest, the friction we observe is static. When the body is sliding, so we use the term static friction, sorry, kinetic friction or dynamic friction. Rolling friction means when the body rolls, we use the rolling friction topic. Like that, according to the situation, we'll be using this stuff. First of all, here what is the static friction means? It is also called as self-adjusting friction. Self-adjusting friction. Please remember what the term I am using is very important. What I used here is self-adjusting friction. Friction will adjust by itself. Friction will adjust by itself. When the body is under rest, whatever the applied force, body is under rest, then the applied force is equal to frictional force. The applied force on the body is equal to, simply I can say, frictional force if body is under the condition of rest. Frictional force. That is about static. Static is self-adjusting. There is one additional point in static. What is the additional point in static, sir? That additional point is nothing but in static, we have to know one more thing is called as limiting frictional force. Limiting frictional force. Limiting frictional force. So limiting frictional force is nothing but maximum value of static, maximum static friction, maximum static friction. In this condition, how the body will be there means body will be in the condition of tends to move or ready to move. The body will be in the condition of ready to move, then the frictional force we call it as limiting frictional force or maximum static frictional force. That is about the information what I provided about limiting. And kinetic means I told sliding. Here, kinetic frictional force, rolling frictional force, I have given some information. Let us see about limiting frictional force now. What is about limiting frictional force? As this is a crash course is going on, just I am giving only formula to you beta. Please just, I'm not discussing in detail, just I'm giving only formula. Go ahead with this one first. You have to understand the limiting frictional force, the idea about friction you have to know. Always frictional force is directly proportional to normal reaction. Normal reaction, N. And frictional force, I can write it as frictional force is equal to mu into normal reaction. This mu is called coefficient of friction. Coefficient of friction. It depends on nature of the materials of the surfaces. So mu is coefficient of friction. It depends on nature of the surfaces in contact. And mu is F by N. It is independent on frictional force and normal reaction. Formula I wrote mu equal to F by N, but it is independent of frictional force and normal reaction. It depends on nature of materials of the surfaces of two bodies in contact. Here, similarly, frictional force means I denote with Fs. Some people will be thinking Fs is static. No, generally I don't represent myself. I don't represent static friction as Fs. I am representing static friction as simply F. Only simply F I wrote here. Here, see here, static I wrote just formality I wrote small f. Formality I wrote small f. So static frictional force I am not representing with the Fs. What I am representing with Fs? Maximum static frictional force. That is called as limiting frictional force. That I am representing with Fs. So here Fs is directly proportional to normal reaction. Fs is directly proportional to normal reaction, and Fs is equal to mu s into N, and mu s is coefficient of limiting friction. Don't call it as static. I'm saying again, mu s is coefficient of limiting frictional force. Don't call it as static. Static, we don't have this formula at all. Static, we don't have this formula at all. Static is nothing but applied force is equal to frictional force. So this is about limiting frictional force. Next, So I hope all the kids got some limiting frictional force idea. After that, kinetic frictional force. Kinetic frictional force. So what happens in kinetic frictional force? Kinetic frictional force. When I'm saying kinetic frictional force, I can write Fk is directly proportional to N, Fk is mu k into N, mu Fk is kinetic friction, mu k is coefficient of kinetic friction. All this stuff is very common. You can understand this coefficient of kinetic friction. You are very clear with these things already in early classes, so no issue at all. Coefficient of kinetic friction. Next, here one note point I want to write relating to static and kinetic. One note point I want to mention. Here, static and kinetic friction, static and kinetic friction, kinetic friction or independent on area of contact between body and surface. Area of contact between body and surface is called as stat. That is what we say. We say it as independent. It does not depend. So more area between the two bodies in contact, more area is there, less area is there, doesn't matter at all. This is also one fine point to be noted. Just note down for formality. Okay. Next, rolling frictional force. So rolling frictional force means, what should I write about that? Rolling frictional force means simply I can write rolling frictional force again as usual is directly proportional to normal reaction. Rolling frictional force is mu r into N. So this mu r is called as coefficient of rolling friction. Coefficient of rolling friction. Here, one point you have to remember is rolling friction depends on area of contact. Rolling friction depends on area of contact. Rolling frictional force is produced because of deformation of the body when body rolls on the surface. Here, if you take a body of radius smaller, the rolling frictional force is directly inversely proportional to radius. Rolling frictional force is inversely proportional to radius. Large body will be having less rolling friction because contact with the surface will be less for large body. So it is inversely related to the rolling frictional force and radius of the body. They are connected as inverse relation. You have to remember this point. Next, we'll be seeing now some applications about this one. First, I have taken one body, and on this body I applied some force in this direction. This is the applied force is equal to F, and body is accelerating in this direction. It is a frictional. Friction is present in between the body and the surface. Definitely frictional force will oppose the body. It's a moving, it is accelerating means the body is sliding. Sliding means sliding friction or kinetic friction, Fk. So I can write here the body is moving right side. See here, the body is moving right side. Right side means right side acting force minus left side acting force. Simple logic. Moving right side means right side acting force minus left side acting force. Right side acting force is applied force. Left side acting force is frictional force. So here, what should I write here is, I know that the frictional force is nothing but mu k into N. We have to remember one point when we are doing the friction chapter, that is any body on horizontal surface. Suppose the body is lying on the horizontal surface. Normal reaction is nothing but weight. So body on horizontal surface, N is equal to mg. And suppose the body is on inclined plane. No doubt, you know that here what will happen? N is equal to mg cos theta, where theta is angle of inclination. So body is on inclined plane. Normal reaction is mg cos theta. And body is on horizontal surface. Normal reaction is simply mg. That's all. So like that we can write this stuff. And MA is equal to F minus FK. MA is equal to, I can write F minus mu K into normal reaction. Just now I wrote horizontal surface normal reaction is mg, means I can write like that. And acceleration is F minus mu K mg by m. This is the acceleration. So this is the acceleration of the body when the body applied force is F and is moving front. Fine, you got some idea. This is the first application I'm taking. Application number, suppose 1. Just for formality, I'm writing application number 1. Next, let me take application number 2. What happened here? Here, the body is having initial velocity u and the mass is m. It traveled some distance and came to rest, v equal to 0. So the body is having initial velocity and coming to rest. Here, there is no applied force. There is no applied force. Initially, the body is having velocity. Because of velocity is there. Suppose you are going on a bike and you switch off the bike. You switch off the engine. Automatically, the bike, when you switch off the engine, bike will not stop there. You didn't apply brake just to switch off the engine. When you switch off the engine, still it has some velocity initially and slowly it will travel some distance and after going some distance coming to rest. The same thing here. That means why it is coming to rest? Question is asked. It is coming to rest because of frictional force. Because of frictional force, the body is coming to rest. So what happened here? There is no applied force at all. There is no applied force at all. So here what should I write? MA is equal to, there is no applied force on this one. The force is nothing but what it is happened, it is decelerating. It is decelerating and coming to rest. MA is equal to minus FK. We already know that on horizontal surface means mu K into mg. I already told you that. From here, what is the acceleration here? It is not acceleration, it is a deceleration. Mu kg, or acceleration is minus mu kg, or simply deceleration is mu kg. I can speak out. The question is asked, how much time it takes to come to rest? How much time it takes to come to rest means v is equal to u plus at. V is equal to 0 is equal to u minus mu kg into t. So t is equal to, I can write u by mu kg. T is equal to u by mu kg. Like that. So here the problem here is S is equal to ut plus of at square. What is the value of here? S is equal, no, I can't take this one because I don't have initial velocity information. I'm avoiding that formula. So first I calculate the time. First I am calculating the time. I'm happy here. But they're asking to find the value of S. They're asking the time value of S. How to find S means I heard one formula. V square minus U square equal to 2AS. V square minus U square is equal to 2AS. So from here I can write, 0 minus U square equal to 2 into minus mu kg into S. Minus cancel. S is equal to U square by 2 mu kg. Very important formula here. S is equal to U square by 2 mu kg. Whatever we are discussing these applications on horizontally, how to know this stuff? Sir, we are doing only formula. No, sir, why you are doing complete application? Why I am doing complete application means if you don't have this knowledge, you can't do anything in the friction chapter. This is the basic requirements. These applications are basic requirements. Next. So you got displacement formula, acceleration formula, time formula, all the three I found here. Next, what is my target is here? S is equal to, I wrote here, U square by 2 mu kg. This is the formula. What I simply did here is, I multiplied in numerator and denominator with the m square. If I multiply numerator and denominator with the m square, I heard that mu is equal to p. So that I can write here, S is equal to p square by 2m square mu kg. This is also in terms of linear momentum, where P is called as linear momentum. So the same formula, what they happen means again they are multiplying numerator and denominator with m. So what happened here? 2 mu k mg, they wrote m and m numerator and denominator. So you can write of mu square is nothing but kinetic energy. I'm writing it as E. So S is equal to E by mu k mg, where E is nothing but kinetic energy. Like that, according to the situation, we have to apply the formula in different ways. This is a thing you have to know how to handle in terms of momentum, how to handle in terms of kinetic energy. That is essential. That way of thinking is essential. Next, let us check the next one. We got this application also. One more application, they are telling that suppose a lorry is there. One lorry is going like that. Let me draw the lorry here. Yes. Yeah, I have drawing one lorry. So what happened means this lorry is going front with an acceleration. This lorry is going front with an acceleration. Backside of the lorry truck, that means they kept one block here. They kept one block backside of the lorry. So the mass of this one is m. The mass of this one is m. It's going front with an acceleration a means what will happen here? It's going front with an acceleration a means frictional force will act backside. The frictional force acting backside here, that is what I can write here is friction force. Why it act backward? No, wrong. Lorry is going front means there act pseudo force will act. Pseudo force is always opposite to the motion. Already in the last class I discussed about pseudo force for you. Pseudo force, what will happen? It is accelerating front means pseudo force will act in back direction ma. So this is now applied force. The pseudo force only will act as applied force on the block. Applied force is left side means frictional force will act always opposite to the motion. Frictional force will act always opposite to the motion. Here suppose this block is accelerating in this direction, A dash. A dash is blocked acceleration. A dash is blocked acceleration. And A is what? What is A? A is lorry acceleration. A is lorry acceleration. So blocked acceleration and lorry acceleration we are taking now. Our target is to find the acceleration of the block, A dash. So see here, the body is M into A is the net force acting on the body. A dash, I have to put M A dash is the net force acting on the body. Net force, the body is going back. The body is going back. A dash I have written. The block on the lorry. Lorry is going front means you just go and sit in the lorry backside. Suppose lorry suddenly went front, you'll go back and fall down from the outside the lorry. So lorry is going suddenly with accelerated front, you'll accelerate backside and you'll fall down. With what acceleration you are moving, that we are going to check here. So ma dash is equal to pseudo force, going backward force is ma, opposing force is frictional force, Fk. We already know that what is Fk means. I heard that mu k into mg. So I can write here ma dash is equal to ma minus mu k into mg. M get cancelled. A dash is equal to a minus mu kg. This is a relation between acceleration of the lorry, acceleration of the block, and everything we can connect in this way. Is it clear? So here we connected with the pseudo force topic. Again, we brought the pseudo force forcibly here and we applied the topic here. This is one application. Next. So we are discussing some horizontal applications from that time onwards. Let us see one vertical application here. This is all the work what I am giving you. This will definitely will help you a lot in your coming exams. So how it will help you means the way of thought, the thought, how to handle the things, that will be clear. See here. M, the weight will act downward and frictional force will act upward. Frictional force will act upward. Your frictional force is acting upward, weight will act downward, and the force, applied force on the block is F. And this is the wall. What we are doing means, I'm keeping some object on the wall. I'm keeping some object on the wall. I'm pressing that object with a force F like that. I'm pressing the object on the wall with a force F. Weight of that block is acting downward. Frictional force is acting upward. So what should I write here is frictional force. It is just stable like that, means upward force is equal to downward force. What is the frictional force? Always frictional force here we can write mu into N. Mu into N. What is N? Here, one thing you have to do, don't forget here. On horizontal surface, the block is there. Then what we wrote, mg, and normal reaction acting upward, n equal to mg. When the body is on horizontal surface. Horizontal surface. But now the body is on vertical surface. Now the body is on vertical surface. Now the applied force here is F. So what will happen? This is how the force is acting is normal to the body. It is acting normal to the body. Is acting normal to the body means what should I write? When a force is acting normal to the body, what should I write here? N is equal to F. Normal force is F. So here simply mu into normal reaction is nothing but here capital F. This is the force acting normal to the body. Normal means perpendicular. See here, this is a plane. Normal to the plane here. If it is horizontal, it will be upward. If it is a vertical, block is horizontal, normal is vertical. Block is vertical, normal is horizontal. So mu into F. So can I write here? F is equal to mg and F is equal to mu into N. There's nothing but mu into F. From these two stuff, already I wrote here. From these two stuff, mg is equal to mu into F. So what should I write here? The mg is equal to mu into F. I want applied force. How much force is to be applied? Such that to keep in rest like that means mg by mu. F equal to mg by mu. That is the formula. What should I to write related to this one in this application when a block is pressed on vertical wall? This application name, ball pressed on vertical wall. A block or ball, something pressed on vertical wall. Like that. Okay, fine. Any other applications, sir? Yes, I want to explain one more application. Now again, I like this lorry. I'm taking another lorry now. So this lorry, what happened? I'm keeping in front of this lorry one block I'm keeping here. In front of this lorry, I'm keeping one block. It's not attached. It is not attached. The block is not attached, just the block. Suppose you can do one experiment. You take one paper and keep the paper on your chest and start running. Your running means what will happen? Paper will not fall down. If I take and keep one paper on my chest, it will fall down like that. If I keep the paper and I start running, I didn't attach the paper to my body, but still the paper is stick to my body when I'm running fast. Why like that, sir? What is the fun in that? Pseudo force will act. What force will act? Pseudo force. Lorry is going with the acceleration A means on the block there acts a pseudo force, that is MA. And no doubt, now what happened? This is MA itself is called. MA is acting in a horizontal direction. That is normal reaction. No doubt, weight will act downward. Frictional force will act upward. So what should I write? Frictional force equal to mg. Frictional force is equal to, I can write, mu into normal reaction. Frictional force is equal to mu into ma. So here, frictional force is mg. From here, I can write mu ma is equal to mg, get cancelled. A is equal to g by mu. So, what I want to say is, if suppose this lorry is going front with an acceleration A equal to G by mu, if the lorry is going front with an acceleration G by mu value satisfied, then the block which is just kept in front of lorry will not fall down, stick to the lorry. Is it clear? That is the phenomena what we observed in this particular application. I hope everyone are clear with this one also. This is also comes under vertical friction. I have given some more application. This is also application I can take under vertical friction. Next, some applications related to inclined plane related. This angle is theta here. Here on inclined plane, a block is there. Whenever a block is there on inclined plane, what will happen? mg, this angle is theta, mg cos theta, and this is mg sin theta on inclined plane. So normal reaction, no doubt, this is normal reaction n. These are the common things. Friction is there or not, these are the common things. Suppose it is they told smooth inclined plane. Smooth inclined plane. It is a smooth inclined plane. They told that this is a smooth inclined plane. So when it's smooth inclined plane, how to handle this one? It is a smooth inclined plane, they told. Yeah, smooth inclined plane, and they told body sliding down from top. That is, suppose here velocity is u, here velocity is v, and u is equal to 0, and it travel from here to here of length is L, and the angle of inclination is theta, and the time taken to reach to the ground is t. Then what is the formula for here is, yes, what we say is coming down with an acceleration, a equal to g sin theta. Time taken is t is equal to root over 2l by g sin theta. And what about velocity when it reaches to the ground? Root over 2gl by into sin theta, v equal root over 2gl sin theta. These are the formulae related to acceleration and time taken to reach to the ground and velocity at a time when it reaches to the bottom. All these values for smooth inclined plane sliding down. Now question arises. Okay, sir, you told smooth inclined plane sliding down formulae. What happens when smooth inclined plane on that it is moving up? So now smooth inclined plane, I am taking again smooth inclined plane, it is moving up. It is moving up means now the velocity with which it is projected up is u, and it is going up with the acceleration a, and it reaches to the maximum height and comes to rest. So here s is equal to L as usual, theta and everything, time taken to reach up. Now, what is acceleration means is going up here. Going up means minus g sin theta. What is the time taken here is root over 2l by g sin theta. Time taken to reach the formula same. And what about the formula for velocity? Where's the projection? Velocity of projection is same as previous. Those things will never change. All the things, if you derive, will get the same as previous. Only the difference between sliding down and sliding up, it is simply a equal to g sin theta, while coming down, going up is a equal to minus g sin theta. That's all. Other than that, we don't find that much difference in formulas. Here, velocity of projection, that is the velocity of reaching bottom. There v is velocity of reaching bottom. Here u is velocity of projection. There is a time for coming down, a time for moving up. Like that, we have to write here, smooth inclined plane. Fine. Now let us observe rough inclined plane. First we'll write now rough inclined plane. Here in rough inclined plane, body is coming down. I'm not drawing all the diagrams and everything. Just I'm giving the equations. Body rough inclined plane down. Rough inclined plane down means a equal to g into sin theta minus mu k cos theta. A into g sin theta minus mu k cos theta. And time taken is same as previous, 2l by g into sin theta minus mu k cos theta. And velocity is square root of 2gl into sin theta minus mu k cos theta. Here, these are the acceleration, time, and velocity. Next, rough inclined plane, again, is coming down with these values we told. Suppose same like previous smooth incline going up. Going up means A equal to minus G into sine theta plus mu k cos theta. Here we get plus sign here. So here T is equal to, we can write root over 2L into G into sine theta plus mu k cos theta going up. Diagrams are comparable with the previous smooth what I have given. You take the diagrams from there. Projection velocity root over 2GL into sine theta plus mu k cos theta. Mu k cos theta. Projected velocity, here it is U. Body projected up with velocity U. It is moving with an acceleration A. Deceleration, actually we don't call acceleration, deceleration. And finally come to rest after traveling a length of L. This is rough inclined plane formulae, what I can write. Rough inclined plane coming down, rough inclined plane moving up. And one more important here thing is rough inclined plane, when you are taking rough inclined plane moving up here, when we are pulling with some force. Previously, we didn't apply the force. Now, suppose I am applying the force is F on the rough inclined plane. So, if we apply the force, what will happen? Mg sin theta, no doubt, opposite. Frictional force, Fk. Fk is nothing but mu k into normal reaction on inclined plane, mu k into mg cos theta. This will also, because going up means frictional force will act down. Body moving up, frictional force will act down. So, it's going up means here, it's going up means upward force minus downward force. Upward force minus downward force means mg sin theta plus Fk. These two are acting down. So the force applied on the body to move up means ma equal to mg sin theta plus Fk, I can write. This is when pulling upward, pulling force on upward here, I can write like that. So from this information, suppose here we can further write this as ma plus, if I take mg common, I can write sin theta plus mu k cos theta, I can write. Moving up with acceleration is moving up with acceleration, moving up with acceleration, moving up with acceleration, moving up with acceleration. Now they are saying that suppose moving up with a constant velocity. Moving up with constant velocity means in the above expression, constant velocity, simply in the above expression, you put acceleration 0. Acceleration you have to put 0 so that it is moving with a constant velocity, constant velocity. I hope all the kids are clear till here. So this is a rough idea I have given. Some rough idea about the formulae related to horizontal friction, vertical friction, inclined friction. I didn't give all applications and everything, just rough idea about the formulae. Okay, then we'll continue in our next session and we'll complete the things. Okay.